Hi all, welcome back to my channel. In the last video, we have discussed about the modern periodic table. In the modern periodic table, 118 elements have been arranged in a very systematic manner. There are some properties related to these elements which define the way in which these elements react. Since the elements are arranged in a very well organized manner, therefore these properties also follow some particular trends. So periodic trends we will discuss about valency, atomic size and metallic and non-metallic characters of all the elements belonging to the periods and belonging to the group. Okay, so let's first define the periodic trend. When the properties of elements in a period or a group of modern periodic table are compared, certain regularity is observed in their variation. It is called periodic trend in the modern periodic table. Okay, in this video we will discuss about the valency of an elements. So let's first recall about the valency. We have learned about the valency in our last grade. To just recall it, we will take some examples. First example is of fluorine. Its atomic number is 9. Electronic configuration is 27. Fluorine have 7 electrons in its outermost orbit. Okay, so any element try to complete its octet, means 8 electrons, try to complete or try to get 8 electrons in its outermost orbit, right, to get stable, right. So fluorine here don't have 8 electron in its outermost orbit. So what it will do, it will receive 1 electrons from outside to complete its octet, right. So its valency become 1, right. So let's take one more example, that is sodium. Its atomic number is 11. Electronic configuration is 281. Now sodium have 1 electron in its outermost shell, right, that is in valence shell, right. So what it will do, it will either accept 7 electrons to complete the valence shell, or it will give this 1 electron to complete the second shell in the octet form, right. So it will be convenient for sodium to donate this 1 electron rather to accept these 7 electrons, right. So what will the sodium do? The sodium will give this 1 electron and complete its octet state. So here we can define the valency as the number of electrons accepted or donated to complete the octet state, right, to get the stability to the element, right. So this is all about the valency. So let's discuss the valency of elements in the same group. So first example of group 1, that is alkali metal. So these are the elements present in the first group, that is group of alkali metals. So we have discussed about the valence electrons of the alkali metal groups in the previous video. Okay, so the valence electrons in all these elements are same. Valence electron means what? The electrons present in the outermost shell, that is 1, right. Here it is 1. So valency of all of them will become 1 now. How? Because the valence electrons is responsible for the valency of an element. Okay, so valence electrons determine the valencies of the elements. So here, as they all have the same valence electron in their outermost shell, they all have the same valency. Okay, here all of them, they will give 1 electron to complete their octet, right. So their valency become 1. Understand? So here we can say that as you go down in a group, as they all have the same valence electron in their outermost orbit, they all have the same valency. Okay, the valency does not change as you go down in the outermost, as you go down in a group. Understand? So let's take one more example to get the concept clear. Here the group number 17, that is halogens. So these are the halogen elements. Okay, here also if you go down in the group, you will find that they all have the 7 valence electron in their outermost orbit, right. That means they will receive 1 electron to complete their octet, right. So they all have the valency becomes 1 now, right. So here also it is confirmed that as you go down in the group, the valency does not changes, right? So, this is the conclusive statement. Elements in the same group of the periodic table have the same valency, right? So, let's discuss the valency of an element in the same periods. Okay, for that we will take the example of period number 2. So, these are the elements in the period 2. Okay, let's discuss their valencies. So, the valency of first element, that is lithium, here it is 1, because the lithium will give 1 electron to complete its duplet, right? Okay, so here valency becomes 1. The valency of beryllium becomes 2. See, the valence electrons in the beryllium is 2. The electrons present in the last orbit is 2. So it will donate the 2 electrons to complete its duplet, right? The valency of boron becomes 3. Valency of carbon becomes 4. If you see the electronic configuration of nitrogen, it is 2, 5. Okay. So what the nitrogen will do? Rather than giving these 5 electrons to the other elements, it will accept the 3 electrons from the other elements, right? So the valency of nitrogen here becomes 3, right? So valency of oxygen here, it becomes 2. The valency of fluorine is 1. Okay. So here the valency of neon, if you see, neon already have completed its octet state, right? So it need not to accept any electron or donate its any electron to complete the octet state, right? So its valency becomes 0, right? If you observe the pattern as you go across the period, the valency first increases to 4 and then it goes on decreasing. Understand? So this is the pattern of valencies of element followed by all the elements in the same period. Let's discuss the one more example, that is period 3. Okay, these are all elements present in the period number 3. Right, see the example of sodium. What the sodium will do? Sodium will give one electron to the other element to become stable, right? Magnesium will give 2 electrons as it has 2 electrons in its outermost shell. Okay, so aluminium has valency 3, silicon has valency 4. Again, see here phosphorus, it will accept 3 electrons to complete the octet. That means its valency become 3. Sulfur, its valency become 2. Chlorine, its valency become 1. And argon, it has 0 valency. Okay. So the same pattern is followed by the elements in this period number 3. Okay. First, the valency goes on increases up to 4 and from there it goes on decreasing, right? So let's see the conclusive statement. So on moving from left to right in a period, valency across the period first increases and then decreases. Okay, so it is applicable to all the periods in the periodic table. Understand, students? So this was all about the periodic trends of valency followed by all the elements across the period and along the same group. Okay, understand, students? So we will discuss about atomic size of all the elements in our next video. Till then, stay tuned with me. Bye.